In question 3 we have the path of a hockey ball. For A part 1 we're to show that the time taken for it to reach maximum height is about 0.6 seconds. Well, for this we can write down SUVAT, S-U-V-A-T. The height in the vertical direction, taking up as positive, is 2.0 meters. The initial vertical velocity is 6.3 meters per second, we're told. The final vertical velocity at the maximum height will be 0 meters per second. Acceleration due to gravity is down, so I'm taking up as positive. I'm going to take acceleration as minus 9.8 meters per second squared, and the time is what we need to find. So we must find this, not use it. Okay, so now we can use V is equal to U plus AT. So V minus U over A is equal to T, which is 0 minus 6.3 over minus 9.81, and this comes out at 0.64 seconds, which is around 0.6 seconds as required. For part 2, we're to use this answer and the diagram to show that the horizontal component of velocity is about 30 meters per second. Well, for this we can use distance is speed times time, which only works when there's zero acceleration. So speed is distance over time. In this case it travels 18 meters in 0.64 seconds, which is 28 meters per second, or around 30 meters per second as required. In part 3, we're after the magnitude of the initial velocity of the ball. Well, I'm going to use the given figures. You could get the marks using your calculated figures, but we have a horizontal velocity of 6.3. We've just found a vertical velocity of 30 meters per second, and we're after the vector sum of these, which is this quantity. And for that we can use Pythagoras, and so the speed v is the square root of 30 squared plus 6.3 squared, and this comes out at 31 meters per second. For B, part 1, we're told the ball has a mass of 0.160 kilograms. We're to find the initial kinetic energy. Well, kinetic energy is mv squared over 2, which is 0.160 times 31 squared over 2, which comes out at 77 joules. In part 2, we're to find the change in gravitational potential energy of the ball as it moves from ground to maximum height. Well, for this the potential energy is mgh, which is 0.160 times 9.81 times the height of 2 meters, and this comes out at 3.1 joules. In part 3, we need the kinetic energy at maximum height, and this will be the 77 joules it started off with minus the 3.1 joules of gravitational potential energy, which gives us 73.9 joules, or 74 joules of kinetic energy. In part C, we're to add to the diagram a path of a ball for which air resistance is significant. Well, this will always be lower than the original line, and it will reach maximum height before the goal, so it will be coming down again before it reaches the goal.